An American tourist captures the ground opening up at his feet. The footage reveals a frequent characteristic of earthquakes: liquefaction.
Okay, we have earthquake right now, and this is actually moving. Can you see the cracks moving? That crack was not there. That crack is getting bigger and smaller, going back and forth. And there is water coming up all over in the park right now.
Loosely packed and waterlogged ground near the surface starts to behave like a liquid. As the ground compresses, liquefied dirt pumps to the surface. Most buildings still stand. Japan's earthquake warning systems work. Scientists upgrade this quake to a magnitude 9, 1,000 times more powerful than the devastating 2010 Haiti earthquake. But everyone in Japan knows this is far from over. The earthquake's explosive energy is about to unleash another destructive force. For centuries, the Eurasian plate is dragged downward by the Pacific plate grinding under it.
The whole upper plate behaves just basically like a rubber block. It just compresses, and like a spring like this. And when the earthquake happens, it springs back.
The upward motion thrusts a 4-mile-deep mass of water upwards. When the dome collapses back, immense waves race out across the ocean. Just 3 feet high and over 60 miles from front to back, the waves travel at a blistering speed. A tsunami is born.
The energy heaved up the sea floor. That displaced vast amount of water that we can see made its way on land, it made its way off around the Pacific.
One side of the wave takes off across the Pacific. The other races towards the coast of Japan.
Tsunamis travel very fast at a speed that depends on the water depth. And because in the deep ocean, tsunami travels very fast, reaching at times the speed of a jet aircraft.
Traveling at over 500 miles per hour, the wave takes just minutes to reach the coast. Here, the shallower seafloor slows down the front of the wave. The wave's fast-moving rear races in. It soon catches up with the front. The increasing pressure pushes the seawater up into a rising swell. 3 miles from shore, a Japanese Coast Guard crew witnesses the growing wave. The tsunami swells up as the seafloor gets shallower. Once they crest the first wave, a second one is upon them. The crew is lucky to survive. Near the coast, the swell becomes a breaking wave. It piles up. A wall of water races toward shore.
The very first thing that seems to have happened is that the sea left the land, and some of the footage we've seen shows a huge shoreline being exposed, and then the tsunami built up offshore, and the dynamics of the wave carried it inland. Probably a cubic kilometer of water just splashed landward, and kept going until it ran out of steam.
This is the moment the first wave roars in. The tsunami has arrived. But there appears to be no clear pattern to when or where the tsunami strikes. First, it hits in the north. Then in the south. Then it strikes in the north again. The height and intensity of the wave varies dramatically from town to town. But why? Part of the answer lies in the